All right, so today we're still going to work with systems of equations, but we're going to learn an algebra method called elimination. Sometimes elimination is called the addition method. Okay, and the main idea that we're trying to do is we're going to add these two equations together, but we want to make sure that when we add them, one of the variables cancels out. So our variables need to be opposite signs, okay? And they need also to have the same coefficient, okay? And when we add things with opposite signs that are exactly the same, they cancel each other out, okay? So if we add 3 to -3, okay, they're opposite sides of the number line, they cancel and make 0, and that's what we're after to try to do here. What I want you to notice with this particular system, we have seen this before, we've graphed this, but this is already set up for elimination because I have an x and a negative x, and they both have coefficients of 1. Okay, so if I add these things together, they're going to cancel out. Okay, so a positive 1x and a negative 1x give me 0x, okay, which basically just means it cancels out. I'm going to do the same to everything else. So I have a negative 5y plus 1y, okay, and that's going to give me negative 4y. Okay. Negative 12 plus 4 is going to give me negative 8. If I go ahead and divide both sides by negative 4 to solve for y is equal to 2. Okay, I have one part of my solution. Okay, so remember my solution is an ordered pair. My y value is 2. Now I need to go ahead and find my x. What I'm going to do is I'm going to take this y is equal to 2, and I'm going to plug it into one of my equations. I'm going to pick that one. It doesn't matter. And I'm going to now solve for x. Okay. So remember my equation is negative x plus y is equal to 4. And now my y is going to be 2. So I have negative x plus 2 is equal to 4. I'm going to subtract 2 from both sides. I have negative x is equal to positive 2. Have to go ahead and multiply or divide by negative 1 to switch my signs. X is equal to negative 2. So my solution for this system is negative 2, 2. I should be able to plug this point into both equation 1 and equation 2 and get the same answer. If you were to graph this, this should also be your solution. And we have graphed this before in a previous lesson, and this is what we got. Let's go ahead, and this is our one solution idea, to where when we go ahead and do this method, this is what one solution will look like. Okay, remember we have 3 different scenarios. Here's another example here. So I'm going to label my equation 1 and 2. And I'm going to go ahead and look at what I might want to cancel. Okay, first of all, neither one of these are exact opposites of each other. So this is going to look a little weird. Okay, so I need to multiply 1 or 2, equation 1 or equation 2, by something so that one of my variables cancels. Okay, now as I go ahead and look through this, it really doesn't matter who I pick, whether I pick x or whether I pick y. So in this example, I'm going to go ahead and cancel y. And in order to do that, I need to take my equation 1 and I need to multiply all of it to make my y's cancel. Now my y in equation 2 has a 2, so I need to multiply this by 2. And I also, they're both minus, I need one of them to be plus, so I'm going to make it a -2 to switch my signs. And then we're basically distributing all the way through. So I have -2 times 3x, which gives me -6x. I have -2 times -y. A negative times negative is a plus. And 2 times my little invisible 1 there is just 2. Equals, I'm distributing it to the 4 also, so -2 times a positive 4 is -8. Right? I'm going to go ahead and put this in my system, and this is now the new equation 1. And I'm going to put equation 2 as it is underneath of it. And something interesting is going to happen here. I set it up so my y's would cancel. That's what I wanted to do. And they do. I have 1 plus, 1 minus. These cancel. Also, if you look at my x values, they are also opposite in the same coefficient. They cancel also. So everything on this side of the equal sign canceled and became 0. If I go ahead and add the other side, I get -4. Now 0 is not equal to -4. This is a false statement. All right, which means this equation has no solution. And if you were to go ahead and graph these, they would be parallel lines. Okay, so this is what parallel lines looks like when you're trying to work it algebraically. All right, so this is this is the second of our scenarios when we have parallel lines or get no solution. All right, let's look at this one. This is going to be the last one. You probably know what this is going to be, but let's go ahead and do it anyway. So I have equation 1, equation 1 and equation 2. It's going to be a little harder to make 2 and 3 match here. So what I'm going to do is I'm going to go ahead and multiply equation 2 by -5. It's much easier to just do it to one equation. Okay, so equation 1 is still 5x plus 2y is equal to 1. The second equation I'm going to multiply by -5, and I'm going to distribute it through. So -5 times x is -5x. A negative and a negative give me a plus. 5 times 3 is 15. And my y stays. Is equal to negative times a positive is a negative. And 7 times 5 is 35. Let's go ahead and add everything together. So my 5x's cancel, that's what I wanted. I have 17y is equal to -34. And then I got to divide both sides by 17. Right? So we got 34 divided by 17, which is 2. And positive over negative is a -2. So y is equal to -2. Okay? Let's go ahead and plug that into either one of my equations. I'm going to go ahead and pick equation 1 to plug that back into. So I have 5x plus 2 times my -2 is equal to 1. So I have 5x minus 4 is equal to positive 1. Add 4 to both sides. 5x is equal to 5. So x is equal to 1. And so my solution will be 1, negative 2. Make sure you're writing them in the right order. Well, I do have one more. Okay, great. So this again was one of ours. This is where we get one solution. Let's look at our last one here. And I have 5x minus 3y is equal to 9. That's equation 1. 10x plus 6y is equal to negative 18, my equation 2. Both of my x's and my y's are opposite signs from the ones below in equation 2. I'm going to go ahead and take equation 1 and multiply it by positive 2. Okay, because the signs are already opposite, I'm going to try to cancel out my x's. So I have negative 10x minus 6y is equal to 18. Equation 2 stays the same. And what you notice is the x's cancel like I wanted. The y's cancel, leaving me with 0. And the 18s also go to 0. And I get a true statement here. This is what the same line type of scenario looks like. Okay, so these two items are the same line. We could tell when we multiply through. And this is that infinite solutions. So every point that lies on either one of those lines is your solution. So go ahead and practice with this. We'll be doing this for a few days. So watch this, work on the problems, and I will make another video later on this week on the same topic.